Welcome to today's Training Tuesday, and thank you for joining our webinar today. My name is Heidi Reese, and I am the Marketing Program Specialist here at Dayton Superior. And I'd like to go over a couple of items before we officially get started. Just want to remind everyone that you are muted when you join the presentation so that we don't have any outside disturbances, but I don't want that to stop you from interacting with me or asking questions, especially at the very end when we have a mini question and answer session. You can do that through the Zoom functionality of the question answer area or chat or both. Just do a little of both. That's great. Also, as a reminder, every one of these are recorded and placed on the Dayton Superior's YouTube channel, as well as daytonsuperior.com. And they're organized by a product page that has all four of the latest and greatest that we've done. And then if you scroll on down, you can get all the additional ones that we've done in the past by topic. Some of them are duplicated on the pages because we want to make sure that you get what you need and how you need it. Just search for Training Tuesday and all of that information can be readily available for you. So this presentation is intended for training purposes only. For technical, I made a new word, technical specifications, please go to daytonsuperior.com and look at the technical data sheets, safety data sheets. All of the information can be found on daytonsuperior.com. So what are we talking about today? We are talking about DBDI, the dowel bars and the dowel ends and dowel outs. What is that, Chuck? See, I need this class too, y'all. So we're going to talk about splicing methods and their definitions, as well as the industry standards around those, and some pros and cons on those splicing methods. And then Chuck's going to provide you with examples and some product information. So I've kind of let the cat out of the bag. Mr. Chuck Hoke is our person who will be training us today. So a little bit about Chuck, if those of you who don't know him, most do. So this, I feel silly every time saying this, and you probably hate it that I do it every time. But he's got 49 years of experience in the concrete construction industry, and he's a very prominent figure in our industry. You think so, Chuck? You think you're prominent? We should turn on the cameras for this stuff. So he spent 20 years dealing in accessories, forming, and chemical products. And then he did 29 of those years at Dayton Superior in various realms. And now he's our training manager for national. And he does all of the training for lots of people. He knows the ins and outs. Whenever we have questions, we know that we can go to him. And if we happen to stump him, which is very rare, he knows where to get that answer, and he always strives to do that. So he's going to share that wealth with us today. You ready, Mr. Chuck?
I'm ready, Heidi. Thank you.
You're welcome.
All right. Good day after Labor Day weekend. Hope everybody had a long, well-rested couple of days off here. So we're going to get started here with our dowel bar introduction of what dowel bar subs are, the DBSAE. Oh, DBSAE, actually, when it was originated back in mid-1970s, is dowel bar structural anchor embed. So I really like the SAE.
You're welcome.
Thanks. And so we're going to talk about it. Basically, it is a threaded splicing system where basically you're going to have a female thread and a male thread. They actually got threaded together. You're going to see some different characteristics within this system here that actually account for why the system has been so popular over the last 40 to 48 years or so. The system is designed so because the current systems back in the day used to be a welded system where basically taking two bars, welding it together. Many of you know that standard A615 grade 60 rebar is not weldable. So unless you provide a special welding method, they have to be joined by electric arc. So you don't find that on a lot of job sites. A lot of guys will have torch and gas on job sites. Lap splicing. Typically you're seeing overlapping of two reinforcing bars. These are becoming more and more frowned upon because of slippage within the structures. And any federal projects now being built typically cannot have a lap splice on them. They typically want to have a mechanical splice. So, and the mechanical splice actually has developed over the years. There's been numerous manufacturers who've been around with this system, and they all have great offering for different conditions within the job site. So one of the most common splices in place are obviously the threaded. And with the threaded, you have two different types. You have a parallel thread and a tapered thread. You also have a bolted system similar to a bar lock coupler. And then we have the grout sleeve systems too. There is also a sledge system on, which has situations where that system comes into play. There's a couple of great systems in the marketplace for sledging if you need to. So when we talk about welded splice, yeah, you got to basically have a arc weld operation with this system here to actually create the weld. You weld on both sides of the rebar. And a lot of times it's one of those you don't know if you get heat sink within the bar to actually create the bar to be weaker than it typically will become from applying the heat. So with the lap splice, you get two bars, you overlap them, tie them together with tie wire, typically 16 gauge tie wire. The problem with this system here, you are relying on the deformations of the rebar and the friction to create your anchorage together. So some of the things, what we've seen with different splicing, why we actually developed a mechanical splice system was because of congestion. As you can see on the different projects here, the project on the right-hand side is World Trade Center system, parking structures where they've had vehicles actually get thrown into the columns. And you can see the bars, the short bar sticking out on the right-hand side. That's actually a lap bar coming in where it actually came apart. You see the congestion in the center picture. It's amazing they can think they can get concrete into the center of that rebar cage. And the same thing on the left, even though they are using a button head or an end anchor in this situation, they've alleviated some of the congestion by doing that. Because otherwise you typically would have another bar running off at an angle on here, a bent bar in place of that button head. So when I talked about earlier about splicing techniques, you got mechanical splices, you've got a tapered thread, a regular thread, then you got a bolted system similar to the bar lock coupler system. For mechanical splices, you typically have, like I said, tapered or parallel thread. They offer precise measurements, so typically you can get within an inch of overall measurement requirements without any too much of a situation here. The parallel thread is a little more forgiving with the thread because you basically, if you have a parallel thread, you don't have to have it tightened right up. So you can actually have a quarter of a turn off what would be the hand tight situation. And you can get a type 1 or a type 2. And we'll talk about what that type 1, type 2 is.
I can't wait.
So we'll talk a little bit about types, loads, and yield strengths. Definitions. Type 1, just FYI, means that the bar splice, the connection between bar A and bar B with the connection in between, will yield 125% of the physical yield of the rebar. That'll take into consideration the strength of the reinforcing bar. Now, type 2 is defined that the bar will, and the mechanical splice will meet the requirement of type 1 and also develop the specified tensile strength, FU, full ultimate, of the reinforcing bar. So, with that being said, what we're looking at strength-wise, and we'll show you here, you've got your A615 grade 60 rebar. Typically the second one down on the grade A615 is 60,000 the specified yield strength. To get a type 1 splice on it, you have to have 75,000 pounds. Specified tensile strength is 90,000 pounds, so therefore your mechanical splice must yield 90,000 pounds to develop a type 2. Now this table is somewhere in mid 2019 or 2023. And what has happened here in the last year roughly is the states have decided, and ACI has decided along with ASTM, that A706 rebar, which is typically a West Coast style rebar, it's a little more ductile than the 615, so it's a lot better for seismic type designs, typically yielded an 80,000 pound strength and specified tensile. So therefore the type 2 was 80,000 with 706. Well, A615 guys would say, well, shit, we're developing a bar here, but we've got to come up with a bar that's actually stronger, a coupler that's actually stronger to meet that specification based off of the rebar side. So ACI actually revamped their system here on grade 60 and grade 80 rebar. They actually down so that both 706 and 615 are now the same. And you have to make sure when your project was put together or as the package was put together or designed, so that you find out what qualifications the engineer required on this project. So splicing loads, typically we got compression, where you're basically pushing the rebar together. The dowel bar subsystem is a very good system in compression and in tension. It will develop a type 2 splice. So what is the yield strength? Yield strength is the stress to which the limits of a reinforcing bar is applied, where once they stretch, the load is removed, the bar will return to its original length. If you think of it a little bit like a rubber band. Specified yield strength is designated by FY. Once the rebar has reached the yield point, the maximum yield point, it has been elongated or stretched and will never return to the original strength. So once you reach that full ultimate strength requirement, you typically will not return back to the original. It will not come back to its original strength. So once you stretch it too far, you're done. That's all. That's where it's going to set. So with the DBDI system, yes, we can do black bar, we can do epoxy bar, we can do galvanized bar, we can even do stainless steel for certain sizes. Typically it's a 2-part system, upsized and hot forged. This is a type 2 grade 60 splice, hand tight, no tools required. Size 4 through 11, fully customizable, perfect form saver application. What makes this a perfect form saver application is that integral washer on the front face of the female component piece gets nailed to your form. That is the strongest washer in the industry. So when our iron workers are walking on top of it, you don't have to worry about that. With a lot of the other splicing systems, they use a small 16 or 18 gauge steel plate, which is very light. This is a very heavy duty application, and it is the only one in the industry that uses a round washer. So, and we do have certifications for this system from the building codes and from ASTM and ACI. So where are you going to use it? Anytime you have a bar protruding outside of a wall. You can also have bars protruding out of a floor. A lot of times when you're looking at large projects here, you're going to have walls that are going to be put up in the middle of the structure. So you're going to have rebar coming up out of the floor to connect to that rebar cage moving on the vertical wall. A lot of times when they get put in, they get run over. They get knocked over, guys. They're just always in the way. It's also a hazard for the guys basically getting cut on these things, tripping over them, not getting knocked over, etc. So by putting in a form saver at this site here and then coming back later and threading in a bar to actually continue on with your rebar cage, you're actually speeding things up because you don't have these breakdowns, so to speak, with the guys while that part of the project is not being developed. So you also have mechanical splices embedded in fresh concrete surfaces. You'll see this a lot in different phases of the job with a mechanical splice. And that's what you'll end up seeing. Now, what will come back here is you'll have to rip through that plastic coating or a paper coating or a thin tin coating over the top of it to actually get to where the threaded section is, and then make the connection. Installation of this system is relatively simple and easy. You take the female component piece. Now it'll already be plugged when it comes from the factory. So what'll happen is you basically take this system, put it up against your formwork, attach it with a couple of screws, and you're good to go. Pour your concrete. After you strip your form, you can basically pull that face off of here, pop the steel plug out of the, or plastic plug out of the threaded area, then thread your female bar, your male bar right into that connection. Now that thread is also a 8-pitch UNC thread. So it is a national coarse thread. And we can help make things a lot easier because we can actually provide these in either hooks versions, whether it be a full hook or a 360-degree hook. We can provide that and make life easier. We'll provide you with a order form so that you can basically run down your list of components, your shopping list, and get your pricing as off of this list based upon what you're looking for your job. Now, we also have our headed dowel systems, our D108 and 108A systems. These are great for holding shelf ledges in place. When I first started in this business back in the 70s, this was number one product that we would sell to nuclear power plants because they use these to hold every shelf angle in place in the country. The system here works really well. You see a lot of this system here holds a lot of shelf angles for projects running through. You also see a lot of precasters use this item. Primarily comes in a 4, 5, and 6 bar. You can also get it in other sizes, but 4, 5, and 6 seem to be the most common size. And typical lengths are going to be somewhere around 6 to 8 to 10 inches long, depending. And they can be both male or female, depending on what type of connection you want to have. We can also do double enders. So for D103, we can also do a double end spacer in a 104A. And we can also do, basically the application you see for it here is typically in a through wall type application. You don't see too many of the D103s, more so the D104s are quite commonplace, especially in a lot of like transit authority projects here where you're going to have subways, trains, or train bridges, et cetera, where they're going to have concrete decks running across. So, and then we have the dowel, the D101 straight splicer bar, basically the DI. Typically, how do you measure? You measure it from the back end of the threads to the end of the rebar. Typically, you're going to be somewhere around 40 bar diameter, 40 to 60 bar diameters is typical, but though that can change based on the specification from the job site. DB is from the front face all the way to the tail because that is the uh, engagement area of the rebar when you're doing a lap with it. And what you can do, if the engineer so requires it, you can actually get these clips, clipped flanges on it. You can get the one clip on the top. Sometimes you may have to do a clip flange clip on the top and bottom, just to make sure you get concrete coverage on the steel. That's all doable at our facility and can be shipped out to the job site. So you'll have two nail holes that you can still make an attachment to and go that way. End anchors. This came on here a few years later here. This product originated back in the mid-80s. We started seeing because a lot of the rebar cages were getting a little bit crazy as far as congestion. So we started developing an end anchor system. Originally, we came in with a system here that is a forged system here. Typically has the mushroom end or the anchor end, typically has a cross-sectional area 10 times that the size of the rebar, so that you're actually getting a type 2 anchored system out of it. Improve safety issues of basically reducing overall congestion. And you see a lot of these guys here on different types of pours here, especially columns and slab intersections or columns with basically like you're doing a pier. They would use like the double end system here to actually connect to each side of the slab going out, and the column would then be in the center of it. This actually enables you to actually have anchorage throughout everything. But these systems here are all readily available from our manufacturing facility out of Tremont and out of Modesto, California. Now the system here working with DBDI, it is here we are doing, you're showing a system here of doing a end anchor where they actually putting a disc on the end of the rebar. You're basically heating that rebar up to about 2,400 degrees and basically shaping it into the shape of the disc, thus creating you a basically 10 times the area end anchor for this system. This system here, this one here is done out in Modesto just because of the direction of the coupler of the machinery. In Tremont, everything we have is what we call a vertical system, so it runs top to bottom. You can see different applications, how the system is put in place here. Back in the early days, we didn't have any covers on a lot of this, so guys would actually either use old soda cans or beer cans.
Beer. You drink
Beer cans, yeah, we drank a lot of beer in our days. Take the steel tab, put it over the cover, or duct tape works really well for it, just to keep the concrete out of it. And then when you strip your forms, you can basically peel off that steel cover or whatever, or duct tape cover, and then thread your bar in. Obviously, the huge thing with this system here is we're going to help speed up form work. Can you imagine having to have rebar sticking out of every one of these holes in your concrete forms? Well, on this system here, you've bought new concrete forms all the way through and through. But what it also does is it speeds up the access because by not having to put all the rebar coming through there, guys don't have to work around it. They can set their forms and keep moving around and then come back. After they strip the forms, the next crew behind it can actually come in, clean up the holes there, clean out the holes, and thread the rebar in to actually make their clarifier system, the cantilever system, concrete system here. And you can see they basically have attached the form to it, reconstructed a rebar cage, formed it up, and now they're ready to pour it. So with this system, we've got available product pages available on the website. Typically, you can put in threaded rebar systems. Go D108, a D101, D101A. Any of those topics will actually bring up all of these different capabilities, and you can actually look inside our rebar splicing handbook for the information. We've got technical data sheets on all the sizes available. Handbooks. Like I said, the rebar splicing handbook has all the technical data sheets inside. A lot of that information comes right from the technical data sheet, is listed in the handbook for your use. And obviously we have our DBDI form system book. Pad you can actually send a pad out to you. This will enable you to actually accumulate everything you need for your project into one system, send it into our customer service reps. They can price it out to you and send it right back to you with the pricing on it. We also have the IMPO evaluation report. These typically are required by most of your ACI and ASTM, and a lot of your states and different agencies will require third-party evaluation reports, and these guys typically handle most of the products all relating to splicing. Now, let's say you don't know who your salesman is. Well, we've also taken care of that for you on our website. We're DaytonSuperior.com. Go into the contact section up on top. This system, then what it'll come back and say your sales representatives, maps, and you can actually come down here to either Dayton Superior or Simons. Your Simons guys, they can actually provide these products to you also, so they can get you pricing and availability on it. Your Dayton Superior reps are listed on here, and we have our technical sales reps that we typically have across the country. We've got one over on the East Coast, one down south, one up in the mid-central, and one out west. Now, one of the great things that I think that is a great addition to our system here at Dayton Superior is we have a great new Build America, Buy America interactive map and research database. This will actually come in with all your BABA compliance, whether it be Build America, Buy America, whether the product is on the approved list for your state, and if it does meet the Build America, Buy America, which DBDI typically meets all BABA requirements because it is made and manufactured here in the US only. So you can actually look this product line up, basically see if your state has approved it. We typically are approved, I believe, I'm going to say probably 85 to 90% of the states running across the country. And those that we aren't approved typically have approved it in the past, but it's on a job per job basis. Now, we can also provide you a certificate of compliances for Made in America, DOT requirements, etc. Any of those any of those other letters of compliance that are required by your state or engineer or your specifying agency can be provided. Now, the great thing about this is it is part of the Superior Deal of the Month.
Tell me more, Chuck.
Hey, now you can place your order, get your pricing today, place your order, and save some big bucks on this product line.
That's right.
So this system here, the DBs and the DIs, standard bar lengths, and what we would typically stock are part of our Superior Deal of the month project. And what you can do is you can place those orders in. Customer service will tell you what sizes are included. So they have a complete list of what is available for your discounted price. And you're gonna save a good amount of money here on these products here. And those are epoxy coated and black bar, because those are the two sizes that we typically stock for it. So
Yeah, it is a great deal, and it's only for the month of September. So contact your sales representative today. Anybody have any questions out there? I see one person raise their hand, but it might have just been an accident. So let me know if you have any questions, put it into the Q&A section or the chat, and we'll get them answered for you. And while we're waiting on that, just a reminder, we do record these. I don't send any emails out anymore, but they will be online about 4 o'clock on the YouTube channel, as well as DaytonSuperior.com. And if you need additional training, there's a QR code right there on your screen right now in the bottom left. Just scan that and it will get to Chuck and I, and we can contact you about what type of training that you need. All right, then, if there's no questions, then that is it for today. And all of you guys have a great Tuesday. We'll see you next week.
have a good day, guys.